How do you keep an army alive for months at sea when there is no refrigeration, no cheap salt, and no supply line waiting beyond the horizon? This was the problem the Vikings faced every time they raised a sail. They crossed open oceans, founded colonies on hostile shores, and raided coasts thousands of miles from home. Their ships carried warriors, weapons, timber, and tools, but above all, they carried food. Tons of it. Yet in Scandinavia, between the 8th and 11th centuries, salt was not abundant. It was scarce, expensive, slow to produce, and often traded like silver rather than consumed like seasoning. The familiar image of medieval barrels overflowing with salt collapses here. And that leads to an uncomfortable truth. The Viking expansion was not powered by swords alone. It was powered by planning, logistics, and food engineering, refined to survive time, distance, and uncertainty. What if the most important Viking technology was not the longship slicing through waves, but the pantry hidden behind the hull, the drying racks clinging to the cliffs, and the barrels buried deep in cold earth? What if their real secret had almost nothing to do with salt at all? Instead, they turned to forces older than civilization itself: wind to strip life of moisture, acid to command bacteria, smoke to alter chemistry, earth to slow decay, and time, patiently controlled, to finish the work. By the end of this film, you will see how the Vikings built vast systems of preserved food, structures that functioned like skyscrapers of survival, capable of feeding fleets for years. And you will learn why one method was so extreme, so precise, that it required burying food underground for months before it could safely be eaten at all. Modern imagination tells us that medieval food preservation was simple and brutal, that meat was drowned in salt and sealed inside towering barrels stacked from floor to ceiling. It is an image that feels logical, even inevitable. But in Scandinavia, this story quietly falls apart. Salt was never cheap in the Viking world. It had to be produced by evaporating seawater, a slow and fuel-hungry process in a land defined by cold temperatures, short summers, and limited firewood. Every handful of salt represented time, labor, and precious energy. For most Viking farms, salt was not abundant or casual. It was strategic. It was reserved for butter, for trade, or for moments of true emergency. Building an entire food system on salt alone would have been reckless. It would have tied survival to a single fragile resource, vulnerable to weather, fuel shortages, and seasonal failure. The Vikings understood this risk instinctively, long before the language of logistics existed to describe it. So they made a different choice. They refused to rely on one preservative, one method, or one assumption. Instead, they engineered a layered system of survival, where multiple forces worked in parallel rather than in isolation. Climate slowed decay, wind removed moisture. Bacteria were controlled rather than feared. Smoke altered chemistry. Earth stabilized temperature. If one method weakened, another quietly took over. This was not cooking in the modern sense. It was planning stretched across seasons and years. It was redundancy designed into daily life. And it allowed Viking communities to survive not because conditions were easy, but because failure in one place did not mean collapse everywhere else. What we are seeing here is not folklore or improvisation. It is logistics at a civilizational scale, built by people who understood that endurance depends not on a single solution, but on systems that adapt when reality refuses to cooperate. The backbone of Viking food preservation was not fire or salt, but air itself. Cold, dry, and relentless, the northern wind became one of the most powerful tools in the Viking survival system. Quietly working day and night, without fuel or supervision. Along the rocky coasts of Norway and Iceland, the Vikings raised vast wooden drying racks directly in the path of constant coastal winds. These were not small household structures. Entire shorelines were transformed into open-air production zones, where preservation happened on an almost industrial scale. The landscape itself became part of the process. Cod caught during the cold months was gutted immediately, tied in pairs, and hung by the thousands. Winter temperatures slowed bacterial growth, while steady airflow stripped moisture from the flesh day after day. Nothing needed to be rushed. Time was not the enemy here. It was an ally. After months of exposure, as much as 80% of the water had vanished. What remained was stockfish, dense and rigid, hard as wood, yet light enough to carry in bulk. It did not spoil. It did not require barrels of salt or constant fire. Properly dried, it could last for years. This made stockfish ideal for long voyages. It was compact, durable, and nutritionally dense, capable of feeding crews far from any coast or supply line. It could be eaten as it was, soaked in water, or broken and cooked when fuel was available. Few foods in the medieval world offered this level of reliability. What matters most is not the fish itself, but the thinking behind it. The Vikings did not fight nature or attempt to overpower it. They positioned their food where wind, cold, and time would do the work for them. Preservation was outsourced to the environment, guided by experience and careful placement, rather than brute force. And fish was only the beginning of what this system could accomplish. Meat followed the same logic as fish, but with even higher stakes. In a world without refrigeration, fresh meat spoiled quickly, and wasting protein in the north could mean starvation before spring. The Vikings responded not with fire or excess salt, but with airflow and patience. Thin strips of venison, lamb, and seal were cut carefully and hung in shaded places where wind could move freely. There was no smoking and no cooking involved. Heat was avoided on purpose. The goal was not taste or comfort, but stability. By keeping meat cool and dry, decay slowed to a crawl. Drying was never about flavor. It was about survival under pressure. Properly dried meat could be eaten raw when fire was scarce, soaked in water to soften it, or boiled when conditions allowed. It became emergency food, war food, and migration food, ready to move wherever people moved. Archaeology makes something clear. This was not occasional household preservation. Evidence shows production at scales far beyond daily family needs. Racks, storage structures, and processing areas point to organized output measured in bulk, not in meals. This was infrastructure designed to support communities, crews, and long-distance movement. Dried fish and dried meat moved far beyond Scandinavia. They crossed rivers and seas, exchanged for grain, metal, and textiles, feeding trade networks that stretched across Europe. Wind did more than preserve food. It powered an economy. But the Vikings were realists. Wind was reliable, but not perfect. In damp or humid conditions, drying could fail. Instead of collapsing, the system adjusted. When air alone was not enough, other methods stepped in, ensuring that preservation never depended on a single fragile solution. When air was no longer reliable, the Vikings turned to something even more powerful: biology. Instead of fighting bacteria, they learned how to control it, and in doing so, they unlocked one of the most sophisticated preservation systems of the medieval world. Viking dairy farming produced familiar foods like cheese, butter, and skyr, but it also produced a constant byproduct that modern eyes often overlook: whey. Sour, acidic, and rich in lactic bacteria, whey was not waste. It was potential. Rather than discarding it, the Vikings put it to work. Meat and fish were submerged in whey inside tightly sealed barrels, then stored underground or in cool cellars where temperatures remained stable. Inside these containers, oxygen was limited and acidity rose. Harmful bacteria could not survive. Beneficial microbes took over the environment completely. Food did not rot in this system. It changed. Texture shifted. Flavor deepened. Proteins broke down in controlled ways that made food both safer and longer lasting. This was not neglect or desperation. It was deliberate transformation guided by experience and discipline. In Iceland, this method became known as sur, a form of fermentation that could preserve almost anything. Fish, meat, even entire cuts that would otherwise spoil were stabilized through acidity alone. No cold was required. No fire was needed. No salt was consumed. What mattered was control. Barrels had to be sealed properly. Timing had to be respected. The environment had to remain undisturbed. When those conditions were met, biology became a tool as reliable as wind or smoke. This was not decay. It was controlled life, harnessed to serve survival in a land where nothing could be wasted. When fermentation reached its limits, the Vikings added another layer to the system: smoke. Not heat and not flame, but smoke itself, used with precision and restraint. Cold smoking was a slow process that transformed food at the chemical level. As wood smoldered at low temperatures, it released phenols and aldehydes, natural antibacterial compounds that settled into the surface of meat and fish. These compounds did not cook the food, they protected it. Over time, they created an environment where harmful microbes struggled to survive. Meat and fish were hung in cool smokehouses for weeks, sometimes longer. Moisture left the flesh gradually, not violently. As it did, thin protective layers formed on the surface, sealing the interior and extending shelf life. This was preservation by accumulation, not by force. The Vikings understood that smoke was only as effective as the wood that produced it. Alder, juniper, and beech were chosen deliberately, not for taste alone, but for the chemical properties released when they burned slowly. Each wood created a slightly different protective profile, allowing preservation to be tuned to local conditions and available resources. Smoking demanded patience and attention. Fires had to be kept low and steady. Airflow had to be controlled. Too much heat would spoil the process. Too little smoke would leave food exposed. This was careful work, repeated day after day. The reward was reliability. Smoked food could survive months at sea and remain safe to eat with minimal preparation. Unlike stockfish, it did not require long soaking or processing before consumption. In this way, the Vikings turned fire into preservation without cooking, using smoke as chemistry rather than heat, and adding another resilient layer to a system designed to endure distance, weather, and time. Not everything could be trusted to wind or smoke. Some foods, especially those rich in fat, spoiled too quickly when exposed to air. Butter turned rancid, meat degraded. For these materials, the Vikings turned to something colder, darker, and far more stable: the ground itself. Deep cellars were cut into earth and stone, tapping into naturally cold layers below the surface. In these spaces, temperature barely changed across seasons. Summer heat never reached them, and winter cold remained steady rather than destructive. Butter, meat, and fish could be kept here for months without active intervention. But the Vikings did not stop at cellars. They recognized that certain landscapes offered even greater protection. Peat bogs, common across Scandinavia and the North Atlantic, were cold, acidic, and almost entirely deprived of oxygen. These conditions halted decay in ways few other environments could. Barrels of butter were lowered into these bogs and left untouched. Years passed, sometimes decades. When recovered, the contents were still preserved. Archaeologists continue to find these deposits today, known as bog butter, physical proof of a preservation method that treated the earth as a sealed vault rather than simple storage. What mattered was not cold alone, but isolation. Oxygen was kept out. Microbial activity slowed to near stillness. Time itself lost its power to destroy. In this system, the earth was not just a place to hide food. It became a natural refrigerator and a long-term memory, capable of holding nourishment safely beyond the span of seasons and generations. Then there was a form of food that, by all logic, should never have existed: the Greenland shark. Fresh, its meat is poisonous to humans, saturated with urea and ammonia that make it dangerous to consume. In most cultures, this would have ended the discussion. But in the North Atlantic, protein could not be wasted. So the Vikings did something extraordinary. They did not avoid the danger. They engineered their way through it. Shark meat was cut into large sections and buried beneath layers of stones and soil, where pressure forced toxic fluids to drain away. Over the course of several months, Urea and ammonia leached into the ground, slowly neutralizing what would otherwise be lethal. This was not improvisation. It was a controlled process that required time, patience, and precise conditions. Once the burial phase was complete, the meat was exhumed and hung in open air where wind and cold finished the transformation. Over many more months, the flesh dried and stabilized. What emerged was hakurl, a food infamous for its pungent aroma and powerful taste, yet safe to eat and capable of lasting for long periods without further preservation. This method was never about comfort or culinary pleasure. It was about necessity pushed to its absolute limit. In a land where resources were scarce and survival was unforgiving, even poison had to be transformed into nourishment. Nothing illustrates Viking resilience more clearly than this process. It shows a mindset unwilling to surrender to environmental limits, a willingness to accept risk, and the discipline to let time do its work until danger itself became food. Preservation alone was never enough. Food that survived drying, fermentation, smoking, or burial still had to be protected from moisture, animals, and careless handling. Without proper storage, even the best preserved supplies could be lost in a single season. Viking communities treated storage as a strategic problem. Food was kept in raised barns and storehouses, lifted above damp ground and beyond the reach of rodents. Barrels were sealed with pitch to block air and moisture. Meat and fish were hung from rafters, where airflow continued to protect them long after processing was complete. Nothing was stored casually. Every location, height, and container reflected an understanding of risk. Preservation methods and storage architecture worked together as one system, each reinforcing the other. When it came time to sail, selection became even more precise. Only the most compact and durable foods were allowed aboard. Stockfish for long endurance, dried meat for flexibility, cheese and butter for dense calories, ale for hydration and morale. Every item had a role. Each voyage was planned like an equation. Calories had to justify their weight. Shelf life had to match distance. Waste could not be tolerated. Ships carried no excess and no margin for error. In this way, Viking ships became more than vessels for war or exploration. They were carefully balanced, floating pantries, designed to sustain life across empty oceans where resupply was impossible and survival depended entirely on preparation. So what truly powered the Viking world across oceans, winters, and generations? It was not salt, not weapons, and not brute force. It was systems, carefully built and patiently maintained. Wind preserved fish by removing moisture before decay could begin. Acid preserved meat by controlling bacteria instead of fighting it. Smoke protected protein through chemistry rather than heat. Earth preserved fat by isolating it from air and time. And time itself, when guided rather than resisted, completed the process. Nothing in this system stood alone. Each method supported the others. When one failed, another quietly took over. Preservation was not a single technique, but a network of overlapping solutions designed to endure uncertainty. This was not folklore handed down as tradition. It was engineering rooted in observation, repetition, and consequence. The Vikings did not survive because they were stronger than their enemies. They endured because they planned further ahead than most civilizations of their time. This is primal heritage, not nostalgia, not legend, but the forgotten intelligence that once determined whether communities survived or disappeared. And it leaves us with a quiet question that still matters today. What systems did we abandon that once kept humanity alive? If this story changed how you see the Viking world, share your thoughts in the comments and join us at Primal Heritage as we continue uncovering the deep logic behind ancient survival. Because the past still has lessons, if we are willing to listen